Hello and welcome back to my RC channel. I'm Andy RC and today I'm going to be taking you through the modifications that I have done to my Eachine X220S. This is the updated version that can take a 5S battery, but before I go through the modifications I just want to point out a couple of things. So I mentioned in a previous video as well that Albert Kim, another YouTube reviewer, received his, and his had a problem, I think, with the ESC. One of his motors wouldn't turn around. And also Bruce Simpson, he also received a dud flight control, I think it was. I think he had to reroute his receiver so that he could get iBus working. Now, fingers crossed, I've not had any problems with mine whatsoever, but I just want to put that out there that there are people having some issues with this model. One thing I did miss in my review as well is that the frame isn't fully carbon. Only the top and bottom of these arms and plates are carbon. It's like a carbon veneer, and then inside here there's like fiberglass or something like that. So that's something that I missed on my review. Other than that though, I've had a pretty good time with this model. So what have I done? Well, the first one for me is a must, and that is changing the props. These are the RotorGeeks HQ5040 durables. I really like them, they're fantastic. The props that it comes with, absolutely no good. It's a shame because you get a lot of them, but just throw them away. So the next thing that I wanted to address was unnecessary weight. This thing, it felt heavy to fly compared to my recent builds, and there's a lot of stuff on there that you can get rid of. First one is the motor protectors. Now, personally, I don't use them. I find them a dead weight. One thing that they do prevent is mud going in the side of your motor, but I try not to fly when it's been raining these days anyways, so I've taken those off. You need shorter screws to do that. I use some spare screws that I've got left over from some Emax motors, and those go in there fine. And the other thing that you're going to need to do is use Loctite here as well, because these did not have any Loctite on them and they were very loose, so put Loctite on them because we have these soft mounts here, which I've kept, by the way. I think those are a good thing. So I've also removed the sides as well, and yeah, I was a bit unsure on removing the sides, to be honest, because if you look here, they kind of are structural. You see on the Alien frame we've got another standoff here supporting this top plate, and we don't have that here. It was using the sides. The thing is though, right, removing the motor protectors, the sides, I have managed to save about 35 grams by doing that, which if you think about it, it's like removing the weight of a Mobius. So yeah, I'm taking the risk. I had a crash with the last one and both of these top and bottom plates cracked anyways, so I imagine in a heavy crash that would happen even with the sides on, so I'm taking the risk. I've removed the sides. And there's another reason I've removed the sides as well. You can see here, this component here, this is a regulator that I've put in. It's a 12 volt regulator, and that's to clean up the noise of the video on this copter, because wow, there's a lot of noise on there and it's been really difficult to remove it. Actually, I haven't managed to remove it completely, but I've managed to remove it to a point that I'm happy with. You always get a little bit of noise coming through from the power system, and in very rare cases you can't notice it, but you could really notice it on this one, so I wanted to address that. I've tried various different regulators and only one of these Pololu regulators worked. The problem with sticking a regulator in there is if you want to use the 5S, it has to be a regulator that can support 5S. This one can. It supports up to 30 volts, I think, so that was the other problem as well. You could use an C filter or low pass filter. Again, it's finding one that can take 5S voltage. You could make one up yourself, I guess, but I didn't do that. I got one of these regulators in, and that seems to do the trick for me. So the overall weight of this model is now 364 grams. It's actually nearly 20 grams lighter than my Impulse Alien build, so it's actually a fairly lightweight model now, which isn't too bad, and it flies great on a 4S. Now, it was a little bit heavy before, yeah, impressed with it now. There are still some areas though that could be improved even further, but it requires quite a lot of work. You see, let me explain. I'm not a big fan of these LEDs underneath here. I think they're a waste. We've got a huge LED strip on the back there, which is all that you need. These ones really just for visual when doing line of sight. And the reason why I think they are a waste is, you see in this stack here, this bottom piece of the stack, this is a power distribution board, and its only use is to power up these LEDs underneath here. When I took all of this apart, there is a 5-volt out on the ESC board, and that is powering up the flight controller and this board here as well. So this bottom board here, it's got built-in regulators, 12 volt, but of course that isn't in use. It's just powered up for the 5 volt, like I say, to power these up. So further modification of this would be to desolder these underneath here, just take these out, these LED boards, then remove the wire through here. That might be tricky because this is a heat shrink here, so that might be quite tight. Just remove this board altogether, because I was reading that some people were interested in possibly fitting a run cam split on this, and if you take this bottom board out and move everything down, then you could potentially fit that on the top. But like I say, that was a lot more work than just removing the sides and fitting a regulator, so that might be something that I do at a later date. But we're gonna save much more weight again, having this unnecessary power distribution board here, because if you look, the motors go straight into the ESCs here. No need for this power distribution board. So that's just my opinion anyway. Right, so the next thing that I'm going to do is take all this apart and show you the wiring that I did. Okay, so I have removed the nylon nuts that frees up the VTX, and then we've got this wire here, so I'm just going to unplug that actually. But this wire here is the voltage, and then the ground, and then the video. And originally, for both the camera and the VTX, so the camera is here, they were both connected to the flight controller, which is VBAT, so it is the power from the battery with no regulation whatsoever. So this is the video in for the camera, and that stays in the same place, and then this is the video out for the VTX. Then the VBAT was connected here, so the red wire, and then the ground here, and you'll notice I still have the ground connected, and you need to have the ground connected to your regulator, otherwise the on-screen display will disappear when you throttle up. So what I did was I desoldered the red wire here and also the black wire, and I lengthened it. So now the VTX power comes from the output of the regulator. I'll just move this around here, it's quite tricky to see. So the regulator, I have put some electrical tape on the back of it and also some sticky tape, and this is the voltage out, so this is now outputting 12 volts, and then this is the ground. So I've got voltage and ground going to the VTX, and then I have got the same for the camera as well. I've lengthened that. So the camera and the VTX are both being powered off this regulator, and then, as I say, you need to connect the ground up here as well, otherwise your on-screen display will flicker and disappear if you don't do so. So in order to get the regulator to go down here, I also had to change the position of the receiver, so I've now put a cable tie around there and the receiver goes up top, and I can feed the antenna through to the XT60 grommet here as well, so that can also go vertical, which is better really as well. So one last thing, this is how I'm powering the regulator up. This side there is a solder pad there for the VBAT, and then that is going down to the regulator V in there. And yeah, there's another wire on there as well, so I've just piggybacked onto it with the ground and also the voltage. Okay, so this is the noise that I was dealing with the stock setup. Not terrible, but just a little bit too much for my liking, so now I'm going to switch to the modified version, and you can see straight away it's much better. It's not completely gone, but now the noise is more from breakup of the video signal rather than noise filtering through from the power system. The on-screen display, it does still flicker a couple of times. As you can see, it was doing that before, but there's no way around that. I was reading regarding the Omnibus F4 flight controller, and they say you must make sure that the ground is connected to the on-screen display as well as connected to the camera. So that's why I connected the ground from the OSD to the regulator. I did try and fly it without doing that, and the minute that you throttled up, the on-screen display disappeared. Well, there you go. Anyway, that is my modification video to the Eachine Wizard. Let me know if you think it's worth it for the clearer video, and I'll link in the below to the regulator that I used for this video. So as always, thanks so much for watching. Please continue to subscribe. Cheers.
See you on the other side. Stay alive. Stay alive. Ooh, I got to keep it together. Keep it together.